All right, so we took a little while to take up our transformations package, which was our investigation from yesterday. If you need to, you can use the solutions that I posted on Edsby for that if you need to review anything there or you didn't catch something. Now, in this transformations package, this equation was introduced to you. And that was the equation that takes our parent function, f at x, and it performs transformations. So here, f at x is representing some parent function. Okay, so in your little package from yesterday, you guys mostly observed parent functions of x squared, so quadratic, and then you also observed the square root of x and how the graph could change based on A, K, D, and C transformations. So the other things that we see in here, A and C and K and D, these are all transformations that are impacting how our function looks. So we talked about how A and C are changes to the y coordinates of the parent function. Or in other words, they're vertical changes. Okay, and then we talked about how K and D were changes to the x coordinates of our parent function, whatever that is, so they are horizontal changes. Okay, so we're going to unpack these below. So our changes, our vertical changes or changes to our y coordinates, they occur when we have A and C values that are anything other than 1 and 0. So we talked about when A is anything that's greater than 1. Okay, you guys basically have this in your summary from the first package, but I just want to make sure that we all have this information. This is vertical. Okay, it is a vertical change, and this causes a vertical stretch to occur. When A is between 0 and 1, this causes a vertical compression. And if A is negative in combination with either of these things, so it might be a vertical stretch, and then if it's also negative, this is also a vertical reflection. So we take our function and we essentially mirror it vertically, up and down. Okay, for C, this one's really straightforward. If C is positive, this will shift our graph up. C units. So if C is positive 2, it will shift our graph up 2 units. Okay, and if C is negative, it will shift our graph down C units. So if C is negative 7, it's going to shift our graph down 7 units. Okay, and then our changes, our horizontal changes from above, you guys also have this in your summary. But if K is greater than 1, this is a horizontal compression. So it's actually opposite of what the A value is. And we will actually, when we tell what the factor is that we're compressing by, so usually like with the A value, we'll say like vertical stretch by a factor of 2, and that means we're taking all of our y values and we're multiplying them by 2 to stretch out the function. We always use the reciprocal of k when we state our compressions and stretches. So it will be horizontal compression by a factor of the reciprocal of k. So when I say 1 over k, I mean the reciprocal of whatever k is. So for instance, guys, if k equals 3, this is a horizontal compression by a factor of the reciprocal of 3. What's the reciprocal of 3? What's the denominator of a regular number? 1. So what's the reciprocal of 3? 1 over 3. So we would say horizontal compression, I'm not going to write out the whole thing, by a factor of 1 over 3. Okay, so with k, once we state the transformation and we do the actual calculation, we're going to use its reciprocal. So k is kind of like, you have to always do like a little reciprocal thing with it. Okay, and if k is between 0 and 1, this is a horizontal stretch by a factor of its reciprocal as well, factor of 1 over k. And if k is negative, we call this a horizontal reflection or flip. Okay, you guys are going to do this so many times in this unit that hopefully by the end of it, you have it like really well down pat. So you don't have to memorize it all right now. You're going to do it a bunch of times on a bunch of different functions, and then hopefully by the time you've done that a bunch of different times, you've kind of got it down. Okay, and then if d is negative, or let's start with positive, I guess. If d is positive, this will be a shift right d units. And this is going to look negative in the equation. Okay, and then similarly, if d is negative, this is going to shift our graph left d units. And it will look positive in the equation. Okay, and I might also get you guys to just add up at the a value. We're going to add by a factor of a after the vertical stretch and vertical compression part. So I'll go down in 1 second if you're not done, but we're going to say vertical stretch by a factor of a, and also vertical compression by a factor of a. Okay, so just add these above. Okay, is everyone good with this? Everyone's got a copy? Can I scroll? Okay. Okay, so we're going to use the function that I showed you guys above and that you used in your little package that you did. We're using this equation here. So we're going to see if we can identify A, K, D, and C, just like we did at the end of our investigation package. And we're also going to list in words what that transformation does to any parent function. So right now we don't have a specific function that we're performing these operations on. It's just saying you could do this on any parent function, so any base function, and then we perform changes to it. Now this one is also asking us in the order which they should be done to the function. So order, you need to do stretches, compressions, and flips first. In other words, you need to do A and K first, and then you need to do shifts after that. So shifts come last, so D and C, they come at the end. This is actually really easy. We're just going to do it the way we read. If you work your way with transformations from left to right, you'll do them in the proper order. So you're going to do A transformations, and then K transformations, and then D transformations, and then C transformations. Okay? So stretches, compressions, and flips first, and then shifts last. All right, so the first part of this is just going to be us trying to identify A's, K's, D's, and C's. So we have one thing going on here. What is this? Is this an A, a K, a D, or a C? Cameron? It is an A, that's right. So A is equal to -1 here. Now when A is 1, that is no change to our function, right? When I multiply something by 1, what happens to it? It stays the same, right? When I multiply 7 by 1, it's unchanged. If I multiply 2 by 1, it's unchanged. So if I multiply a function by 1, it's unchanged. But if I multiply it by -1, that's actually going to flip my entire function. So this is a vertical reflection, or you can say vertical flip. Okay, there is no stretch or compression that happens from the value 1, but the negative part of this causes the vertical reflection. Okay, so that's the only transformation that we have in this equation. Okay, number 2. What do we have here out of A, K, D, and C? Moving down here. Josh. So I only really have 2 numbers here, so I don't think I can have an A, a D, and a C.
Oh, sorry, I was looking at
Oh, that's okay. Do you want to try 2 for us?
so A and then K.
Yes. So here A is 2, and K is 1/3. Okay, can somebody tell me how we would state the transformation using what we just wrote above on the previous page? How would I write the transformation for when A equals 2? What does this do to my graph, and what is it by a factor of? Paige? It is a vertical stretch by a factor of 2, that's right. Okay, K is a little bit more challenging, so you have to kind of like use the reciprocal of this. Does someone want to take a guess as to what a K value of 1/3 is going to do to our graph and how we would state that in words? Let's start with vertical or horizontal. Is this vertical or horizontal? Okay, so we've got that part. This is horizontal. Now, is this greater than 1 or between 0 and 1?
Between 0 and 1.
Okay, so if you look at your summary that we just wrote, what does the K value between 0 and 1 do to our graph? Okay, and what would we say by a factor of here? So essentially 1/K just means reciprocal. So what's the reciprocal of 1/3? Or just 3, right? Yeah. Perfect. Can I scroll up here? Okay, let's go to number 3. Can someone identify AKDC for us here? What do we have? Lauren?
A is 3.
Mm-hmm.
There's no K.
Okay,
D is -2.
very good.
And C is -1.
Awesome. So notice how she changed the sign of the D value that appears in that equation, because remember, D looks opposite of what it actually is in there. Okay, so what would we say for an A value of 3? What does this do to our parent function in words? George?
It's a vertical stretch by a factor of 3.
That's perfect. Vertical stretch by a factor of 3. D value of -2. Anyone want to take a guess on that one? Charlie?
Should be a horizontal shift to the right.
Not to the right, actually.
The left, right?
Yes. So when D is negative, it will look positive in the equation. That will shift left. Okay. You actually don't really need to say horizontal, because if we're going to say left and right, that is horizontal, so it's a little bit redundant. If you do, it's not a big deal. But we can just say shift left 2 units. Okay, and then a C value of -1. Does someone want to guess on that one? Charlie, do you want to try that one?
Usually shift down.
Perfect. Shift down 1 unit. Perfect. Okay, and notice as well, I'm doing these in a specific order. We're making sure that A's and K's come first in our list and D's and C's come last in our list. So it is important that you do A first and then D and C after that. So maybe we can even just like number them here. This is the order that we'll do them in. Okay, number 4, AKDC, what do we have? Charlie? Okay. Perfect. And I like that you switched the sign of the D value as well, so that's good. Okay, what do each of these things do to our parent function? Who wants to do A for us? Cameron?
Give us a vertical compression by a factor of
4?
1/4.
Yeah, 1/4. Okay, leave A exactly as it is. It's only K that you do the reciprocal for. Very nice. Want to do the next one?
Yeah, this should be a horizontal stretch.
You guys agree?
Oh, no, horizontal compression.
Yeah, so it's kind of like opposite of what the A value is. So you just have to remember that K is the opposite of what you expect. So this is a horizontal compression by a factor of
1/2.
the reciprocal 1/2. Perfect. Okay, and a D value of +1.
Shift to the right.
Okay, shift right 1 unit. Perfect. And note again, I did A and K first, and then D would be done last because it's a shift. Okay, so you guys are going to try out number 5 here. See if you can identify A, K, D, C. And I want you to see if you can write what each of these does in words to your function. So I'm going to give you a little head start on that one, and then I'll start writing it myself, and you can check your work. Okay, so here are our solutions here. We went over A and K, so the negative part is the reflection part. The number part is the vertical stretch compression or horizontal stretch compression. We also want to make sure we use the reciprocal of the K value here when we state the stretch factor. D, you should have written as -2. Remember, we want to change the sign in the equation there. So make sure that you've written that as -2. That should have been a shift left 2 units. And C is +7, shifting our graph up 7 units. Okay, so that's what you should have had for your solutions there. Can I clarify anything there? George?
Does it matter whether you say it's reflected or stretched first?
No. Okay, so if you say vertical stretch by a factor of 5 and vertical reflection, totally fine. Okay, the big thing is that we want to make sure we list A and K first and D and C last, because the shifts all have to come last. Good? Okay, so we're going to list the transformations in order, and then we are actually going to see if we can perform some of these transformations on our graph here. So the first thing that we want to do is in our function here, I want us to identify A's, K's, D's, C's. So what do we have here? Lauren?
A is -2.
Okay. And?
C is -1.
That's right. So we have an A and we have a C. What does the A of -2 do to our graph? Charlie? Okay. That's part of it. And vertical reflection, good. Oops. So that's one of the transformations there. And then our other transformation is a vertical reflection. Oops. All right, and a C value of -1. What does this do to our graph? Charlie? Vertical, so we can just say shift down 1 unit. Perfect. Oops. Okay, so I'm going to kind of actually label these. If you guys have a couple different colors, it might be nice to have those, because I'm going to show you on the graph what each of these functions or what each of these transformations here is actually going to do to our graph. So I'm going to do 1, 2, and 3 here. Okay, so number 1, this is the vertical stretch by a factor of 2. I'm going to choose a couple little key points along the way here. You can use as many as you want. Like if you want to use every single point, like you can use 1, 1 if you want. I think I'm just going to choose kind of like the important points along here. So as long as we have a few of them. Again, you can also use 1, 1 and 3, 2 and 5, 3. But I don't think we need like that many points. So I'm just going to use these 4 important points here. So our f at x points are the points 0, 0, 2, 2, 4, 2, and 6, 4. So in transformation number 1, when we transform, number 1, when we stretch by a vertical factor of 2, or vertical stretch by a factor of 2, is vertical a change to the y coordinates of the function or the x coordinates of a function? Which one of these is vertical and which one of these is horizontal? Vertical is y. Okay, so if we say vertical stretch by a factor of 2, we take our y coordinates and we multiply them by 2. That's the first transformation. Okay, so we get the x's stay the same. There's actually no horizontal transformations here. We get 0 times 2, which is 0, 2 times 2, which is 4, 2 times 2, which is 4 again, and 4 times 2, which is 8. Okay, so let's take a look at what this graph looks like after we've stretched it vertically by 2. I have this point here. Maybe I should have done these in black. Okay, so for the red transformation, we have a point at 0, 0. We have a point at 2, 4. We have a point at 4, 4. And we have a point at 6, 8, all the way up here. It needs to still have the same general shape as the original function. It's just going to look like it's kind of stretched out a little bit. Okay, so does this look like we took our function below and kind of like grabbed it and stretched it like this? So that's what it should look like if we stretch it vertically, like as if we pulled our function, like that. Okay, so that's the first transformation. The second transformation here is the vertical reflection. And basically what this means in the second transformation is that we'll take our y's and we'll multiply them by a negative. So we're going to take the y's and multiply them by a negative. Again, x's stay the same. But all of the y's should flip signs here when we multiply them by a negative. So actually this graph needs to go down a little bit further. It's not. We can just extend it though. So we'll do 4, 5, 6, 7, 8, 9. Okay, so now our new points are 0, 0, 2, negative 4, all the way down here, 4, negative 4, and 6, negative 8. So it's as if we're taking this red function and we're flipping it upside down. So again, it should still have that same general shape as the original function, but it's going to look a little bit different, obviously. So we stretched it, and now we're flipping it. So there's our function. And then the last transformation here is asking us to shift down by 1. So when we shift down, this is like an addition and a subtraction. So we'll take our y's and we'll subtract 1 from them. That's how we move each of them down a unit. So again, x's don't change. We don't have any horizontal changes here. But the y's, we're going to take each of them and subtract 1 from them. So 0 subtract 1, 4 subtract 1, 4 subtract 1, or negative 4 subtract 1, and negative 8 subtract 1. So here's our new points. Basically, all of them are just shifted down on the graph 1 unit. Okay, and this would be the final graph right here after we've done each of those individual transformations. Okay, you guys will kind of start to get the hang of like what each of these looks like, but essentially like this is basically showing you the operation. So see how we're subtracting 1 here? When we want to shift down 1, we're subtracting 1. So it looks like very similar to what you're doing in the equation. Here we're multiplying by 2 and also a negative, and here we multiply by 2 and then we multiply by a negative. So basically the equation kind of shows you what you're supposed to be doing. Okay, let's try a couple more here. Is everyone okay if I scroll? Okay, let's take a look. List the transformations in order. A's, K's, D's, C's, what do we have here? Lauren.
A equals 2 and D equals negative 1.
Perfect. Can somebody tell me what these do to our graph? Charlie? Yep. By a factor of? Very good. Sometimes for by a factor of, we use BAFO, just to save ourselves a little time, by a factor of 1 over 2. You guys can do that as well. Okay, and then d value of -1, that will be our second transformation. Charlie? Okay. Yeah, we don't have to say both. So shift down 1 unit. Perfect. Oh yeah, actually that's true. Good catch. Shift left 1 unit. D value shifts left and right. I didn't catch it either, so. Okay, so both of these are horizontal transformations. Are these transformations to the x coordinates or the y coordinates? They're both changes to the x coordinates. So if we look at our graph of f at x, this is the graph of f at x. I'm just going to write down these points that are on the graph here, and then we're going to do some calculations to those points. So we have the points -3, 4, 1, -1, 2, 3, and 4, 3. That's our parent function for this particular question. Now the first transformation that we listed there is a horizontal compression by a factor of 2. So you guys told me that horizontal is an x change, right? So we would be changing the x coordinates of the function. Does anyone have an idea of what operation we would do to our x's if I'm horizontally compressing them by a half? George, what do you think? Times by a half or by 0.5. Yeah, perfect. So we'll take each of these and we'll multiply them by a half to do the x's. Yeah, so we'll half each of our x's. The y's will stay the same throughout this whole thing because there's no changes to the y's. So our new points, half of 3, that's -1.5. Y stays the same. Half of 1 is, of course, 0.5. Y stays the same. Half of 2 is 1, and half of 4 is 2. So here's what our graph looks like. It should look like we take this blue graph and like put it in like a little compressor, so it should look like it all gets compressed horizontally. So let's see. 1.54, 0.5, -1, 2 goes to 1, and 4 goes to 2. So here's our graph. Gets compressed. Okay, and then any thoughts for how we can do the shift left 1 unit? What would we do? This is a change to the x, so what are we going to do to our x coordinates here? So not multiply, because that will cause a reflection to happen. Okay, D's and C's are like additions and subtractions. So if we're trying to shift left 1 unit, it will be x subtract 1. So we'll take away 1 from all the x's. Essentially, we're just shifting them all over. Or I guess from your point of view, it would be this way. So take away 1 from each of these. So we'll get -2. Remember, I'm just doing this to the x's because it's a horizontal. Take away 1, take away 1, and take away 1. Okay, this should be our final function because it's our last transformation here. So we're basically taking each of these points and just shifting them left 1 unit. Okay, you probably could have done that without subtracting 1. You can just look at your graph and do it. And here's our new graph. Yep.
How would it go from -1.5 to -2.5 after you're subtracting 1?
Do it in your calculator. I'm subtracting 1, right? So I'm putting more negatives in there, so I get a bigger negative. Make sense? Okay, so that should be the final graph there, the green one. Is everyone good? Okay, I'm going to show you guys one that has like both A's and K's and D's and stuff like that, so both types of transformations. Can somebody tell me what each of the transformations here are for number 1? What do we have? A, K, D, C? A is 1/2, perfect. That will be the first transformation. D is +3, very good. C is what? Okay. Can somebody tell me what each of these do to our graph? Cameron, you want to start us off? Very good. Vertical compression by a factor of 1/2. D value of 3, what does this do to our graph? Charlie? Yes, shift right 3 units, beautiful. And then C value of 4. Where's my spinny wheel? Where did it go? There it is. Oh, orange. C value of 3. Lauren.
It shifts up 4 units.
Perfect. Shift up 4 units. Okay. Mark out your points from your original function. I think like a couple of these, like where it kind of bends, are the important points. So we'll call this is going to be our function f at x. Here are f at x points. There's one at 0, 1. There's another one at 2, 5. Oops. There's another one at 4, -1. There's one at 8, 1, and one at 10, 1. Okay, first transformation, vertical. Is that a change to the y or x? Vertical? It's the y. And I'm compressing it by a half. So I'm going to take all my y's and I'm going to half them. So half for the y's. We will get all the x's remaining the same. This is a vertical change, not a horizontal change. So recopy out your x's. And then you're going to half each of your y's. So that will be 0.5, 2.5, -0.5, 0.5, and 0.5. That's the first transformation. Okay, so you can sketch your graph here. It should, like, you guys could probably visibly look at your graph and kind of see what's going on here. You should notice that all of them are kind of like being compressed by that factor of a half. Oops. Okay, again, this graph should have the same general shape, but it's going to look slightly different. That was a bad line. There we go. You guys get the idea. Okay, so there's the first one. We're going to do the second one and the third one at the same time. Okay? Shift right 3 units. Is this a change to the x coordinates or the y coordinates? If it's horizontal. Horizontal is a change to, Josh? X. Okay, so we're going to do x's plus 3. And then for the C value transformation, if I'm shifting up, what does this do to our graph? Is this a change to the y or the x? Shifting up. Y. So we'll take each of our y's and we'll add 4. So based on these red points here, you guys are going to add 3 to each of your x's and add 4 to each of your y's. That will shift them all right 3 and then up 4. Okay, so add 3. And then add 4 to your y's. and then we're going to plot. So we might need to just extend our graph just a little bit off here because we have to go up to 13. So 3, 4.5, 5, 6.5, 7, 3.5, 11, 4.5, and then 13, 4.5. So here's our graph. So we essentially just took that red graph, shifted it right 3 units, and shifted it up 4 units. This will be our final graph. Okay, so C and D, they're like additions to your x's and y's. K and A, they're like multiples to the x's and y's. So that should be your final graph there. Any questions on this one?
Would that be the amount of work you would like expect on the test?
So for now, we're just kind of getting to know how to do these transformations. I'm going to show you guys a way as we progress in the unit to do them just all together, all at once, so that we don't have to write this out. But just because we're getting to know what each of them do, I want you guys to be able to see it visually. So for this lesson for today, we'll do them kind of like step by step. But yeah, we're going to put it all together after so we don't have to keep rewriting things out. Okay, so you guys have some graphs on your worksheet for today. Let me just pause this video first.